Hello.
Hi, welcome back from intermission.
Go ahead.
I'm Sinclaire Manning, also known as Major Merger.
And I am Brian W. Mulligan, also known as Astrobit.
And we are here to give you this month's top news stories in astronomy.
If I have the clicker.
Yeah. All right, so you guys just learned all about protoplanetary discs, so you're experts by now. So planet-forming disks of gas and dust typically orbit around the equators of stars, but now astronomers have discovered these disks can exist perpendicular to how we've typically seen them and encircle the poles of the stars instead. So that's what's in this artist's impression up here. You have the two stars circling each other, and the ring of gas and dust is going perpendicular to their equatorial planes. Huh, indeed. That is the right response. So Grant Kennedy at the University of Warwick and colleagues focused on circumbinary planets for this study, which are planets that orbit around binary stars, as it has been suspected that planets could become misaligned around these systems. So they have detected the first example of a misaligned circumbinary protoplanetary disk around the quadruple star system HD 98800, which is, thank you, I appreciate that, which is located about 146 light years from Earth. So using the Atacama Large Millimeter Array in Chile, which was the same instrument used to detect those protoplanetary disks in the previous talk, astronomers have captured high-resolution images of the protoplanetary disk around 2 of the 4 stars and found the disk to be about the same diameter as our solar system's asteroid belt. So if planets did develop in this protoplanetary disk, they would have an incredible view from their surfaces. The disk itself would resemble a thick band rising almost straight up from the horizon. So if you're looking out from the surface, you'd see this thick band of gas and dust rising straight in front of you. And then depending on the season, sometimes there would be 2 suns out during the day, causing double shadows, which I feel like has been in Star Trek or something. Or Star Wars, thank you. So this is yet another example adding to the wide variation found in exoplanet environments, and further expands our understanding of where other planets may form.
Pretty cool.
Yeah.
All right. So astronomers may have seen a black hole forming in a cow. More specifically, supernova 2018 COW, known as the cow.
Is this a spherical cow?
It is probably, actually no.
Some people get that joke.
We figured out this one is not a spherical cow. Physicists are so disappointed. So this event, it was first detected in June by a system that was actually designed to identify asteroids that might kill us someday. It's unusual not just for that, but also for the fact that it started off as brightening up as most supernova, but then got brighter than expected, and then got a lot fainter than supernova normally get in the same amount of time. So it got bright really fast and then got faint really fast. It also looks really unusual in its spectrum. We were looking at examples of Lyman alpha. There's a bunch of other elements that have similar lines. These all look really weird and show up at weird times. It's doing all kinds of things that supernova just don't do. So it's also got weird spectra in gamma rays and radio waves all over the spectrum. A number of hypotheses have been proposed to explain this, including merger of neutron stars, merger of a neutron star and a white dwarf, a black hole kind of gobbling up another star, or even just like a regular supernova, but the things around the supernova are really weird. So all these hypotheses relied on limited data about what was going on, limited data about the light. The most recent study by Dr. Raffaella Margutti was the most comprehensive in terms of the range of wavelengths. Looked at radio, at regular light, at X-rays, and at gamma rays. And the data that she found tends to favor the idea of a supernova with something extremely energetic in its center that's emitting X-rays. Theory has suggested for a long time that black holes form in massive stars, in supernova. We often find neutron stars in the sites where supernova occurred thousands of years ago. This might be the first time we've actually seen a supernova, or the evidence of a supernova forming inside of evidence of a black hole forming inside of a supernova itself for the first time. So this is extremely exciting if this works out to be true. Jury's still out, as usual.
Okay, I Googled extensively how to pronounce this correctly, but if there are any Chinese speakers in the room, feel free to correct me. So on the night of January 2nd, China's Chang'e 4 mission touched down inside the 115-mile-wide von Karman crater, which lies within the huge South Pole Aitken Basin on the moon's southern hemisphere. Now, the Chang'e 4 lander and rover are facing their first freeze and long lunar night on the far side of the moon. So the lunar day and night are equivalent to 14 days on Earth. So for 2 weeks, the lander will be in sleep mode due to the lack of solar power and rely on a radioisotope heat source to maintain warmth. So as of now, it is unclear just how cold a lunar night can be, but Chang'e 4 is equipped with dozens of instruments to collect temperature data, which will then be transmitted after the probe is awakened during the next lunar day. So Chang'e 4 is the first ever craft to land on the far side of the moon, and China's lunar exploration will continue with Chang'e 5's launch later this year, which is expected to bring samples of the lunar soil back to Earth. And it was also just announced, I think today actually, that a cottonseed has sprouted on board Chang'e 4, making it the first truly otherworldly plant in history. Yeah. Pretty cool.
All right. So a newly discovered planet was found using citizen science. It was announced just last week at the American Astronomical Society meeting in Seattle. Seattle, or Sinclair just came from.
My hometown, yeah.
So the data from the Kepler mission requires checking by people in order to verify that it is actually a planet or identify the planets in the data. It's really complicated. So citizen science is a great way to do this. There's been two major programs. The first was called Planet Hunters, hosted by Zooniverse, and the more recent one is called Exoplanet Explorers. I think it's also on Zooniverse, so go ahead and check it out if you're interested. It's working with kind of poor quality data or high noise data and trying to identify these planet candidates in it. The second candidate out of this program just was announced last week. The planet's now called K2288. Always exciting names we've got. It's about twice the size of Earth and relatively temperate, having an average theoretical temperature of about minus 50 degrees Fahrenheit, perfect for you Alaskans, Minnesotans, and Canadians. If the planet has an atmosphere, the greenhouse effect also might allow the temperature to be a little bit warmer, so it might be closer to freezing, and there's still some uncertainty in the temperature, so it might even be a little bit warmer than that. Who knows? We'll still figure it out. After being identified as a candidate by the citizen scientists, Adina Feinstein, who's a research scientist or a research assistant at the University of Chicago, followed up using the Keck telescope to confirm that yes, this indeed is actually a planet. And discovered all the temperature characteristics and all that sort of thing. So very exciting. Given the quantity of data still available from the Kepler missions, Exoplanet Explorers still has lots of planets yet to find. So again, if you're interested, go out and look it up and try to find some yourself.
Yeah, people ask us all the time how they can get involved in astronomy if they're not astronomers, and Zooniverse has projects on exoplanets, on galaxies, runs the whole gamut. So definitely check out the website.
It's pretty cool. I'd also say I've tried to do some of these transit planet identifications myself. I don't know how to do it. I don't understand it. But if you can figure it out, good for you.
You can get on a paper too.
Yes. Yeah, there was like 10 authors on this paper, half of whom were citizen scientists.
All right, another I've been watching too much Great British Bake Off over the break. Another groundbreaking spacecraft news. NASA's New Horizons spacecraft made history again on January 1st as it captured the first resolved picture of 2014 MU-69, also known as Ultima Thule, making it the most distant planetary flyby ever. So the historic imagery reveals that the 21-mile-long object is a contact binary composed of two roughly spherical lobes. So the two lobes are red, they're icy surface material likely discolored by radiation, and they were once separate free-flying objects. Scientists believe they coalesced long ago, just after the solar system's birth. It is not thought that this was a violent event, though, but rather the two bodies are thought to have come together at about walking speed, more akin to a spacecraft docking than a collision. So that's kind of lovely if you think about it. They just sort of met up.
Gradually.
And we're connected forever. So 2014 MU-69 resides about 4 billion miles from the sun and is an exciting discovery, as New Horizons team members believe we could be looking at something that represents the oldest and most primitive objects that can be seen anywhere in our present solar system. So stay tuned, though, because this image was taken, or the one on the screen was taken before the closest approach, when New Horizons was 18,000 miles away from Ultima Thule. At the peak of the encounter, the spacecraft got within 2,200 miles, so there will be even higher resolution images on the way if they haven't already been released, and I just missed them.
It takes a long time for data from New Horizons
True.
to get to us, so
True.
it's probably going to be like months away, I think. I don't know.
Weeks, months, keep a lookout.
Oh, wow. All right, so our final story is called Astronomy Not in the News, where we cover research that's generating discussion within the astronomical community, but hasn't necessarily made it into mainstream news. This month's story is about the difference between black holes that are observed through X-rays and those that we found through the evidence of gravitational waves and mergers through the Gravitational Wave Observatory LIGO. So black holes are formed, as I said before, in the depths of massive stars. When gas and dust fall into these black holes, it emits X-rays, which allows us to see them. Most black holes found through the X-rays have a mass between about 5 and 20 times the mass of our sun. The black holes found by LIGO tend to have a mass between about 20 and 50 times the mass of the sun. And these are two completely separate things. We see either X-rays from the lower mass ones or mergers in the higher mass ones. And we didn't understand why we're never seeing, high mass X-ray black holes or low mass merging black holes. So Professor Rosabella Perna at Stony Brook has suggested the reason for this might be that these two separate sets of black holes only happen or only go through these events in completely different environments. So the low mass black holes exist in environments kind of like the area near the sun where there's not a whole lot of stuff. And so in this place, they're able to start gobbling up gas and dust and start emitting X-rays so that we can see them. But if they're in a really dense environment, other things happen that tear the gas and dust away, so we never get to see them. And vice versa, these higher mass black holes need the high density environments like clusters where they can find one another and start merging, and the lower mass black holes just don't get that same opportunity in clusters, so we never find them that way. So it's a logical explanation for this weird bias or weird difference that we see in these two data sets. So this is hopefully a good explanation of why we're seeing these weird things in our results. All right.
That's all for us.
That's all I've got.
All right. See you
Thank
next
you.
month.
That's news for this month.
Enjoy the rest of the show.
Enjoy the rest of the show.